So, what did you pick out as maybe the hardest two or hardest one?
46.
46.
No. 47.
I.
48.
How about 40? How about 48 and 49?
Yep, those are
49 is a good one.
Yep, that's good one.
So, for 48 and 49, why didn't you like them? What's nasty about them, or what's? Yeah, number of variables. That's kind of annoying.
49 has got those fractions.
Raised to the negative exponent.
Yeah, negative exponents. So let's talk about in 48 here. What would be a nice first thing to do? There's lots of different orders you can do these things in, but what would you like to do first?
Get rid of the negative.
I like getting rid of the negatives first.
Yeah.
I like getting rid of the negatives first. I agree with that. I like that. The other methods are totally fine. I just like getting rid of the negatives first. If you do that, you end up with 4z squared over 25 x to the fourth y squared x squared yz. Can you see why that happened? What happens when you have a negative power? Where does it transfer? Or from bottom to top or top to bottom, right? Flips it one way or the other. Now, what can you do? Yeah. 4z squared over 25x to the y to the, and then z. Now you can simplify a little bit. Cross out a z and end up with 4z over 25 x to the 6th, y to the 3rd.
Yes, correct.
Correct? Yeah, that's it. No, what? Don't force it. I guess that's another rule. Don't force it. What did you go further? There's no. Where else are you gonna go? Yeah, illegal math. Okay, so what about 49 here? What's different about this one?
Not much.
Yeah, double fractions. You don't really like it too much, but get rid of that negative by flipping. So you get y over x squared, y over x to the fourth.
You can add them up.
So y to the 6th over all over x squared y cubed. So that's going to be y to the 6th x to the 6th times 1 over. So that's going to be y to the y cubed over. Yes, that is correct. Absolutely. Good. Correct? Okay. Yeah? Nope. Okay. Any others pique your interest on this sheet? Any others pique your interest? None of them? Okay, all of them did. What about 59 and 60? Let's talk about 59.
59 is very easy.
Yeah.
What should you do with 59? What do you do? If anybody says cancel the fourth power, I'm going to get sad.
Don't
Yeah, what do you want to do?
You can just take 666 over 222 and find out what that equals. Or you can take it to the
Or
fourth
you
power.
can-
To the fourth power. That's one way to do it, and that equals 3 to the fourth, which is... Or, another way you can do it. Yeah, you can factor 666, which is 3 times 222 to the fourth over 222 to the fourth, which is going to be 3 to the fourth, 222 to the fourth, all over. And what cancels? Yeah. There it is. Different ways, same answer. That's great. Now, what about 60? You're not using a calculator. What should you do first to clean up 60? That's not a verb.
Well, they have same power.
Yeah. There's two ways. We'll do both ways, Danilo. 1/10 to the third, 20 to the third. Right? Should you multiply that out? No. What do you do with that power of 3? It's the same as... Yeah. What's 1/10 of 20? There's one way to think about it. Absolutely. Another way to think about it. What is 1/10? What is 10? 2 times squared. And what's 20? 2 times 2 times cubed. Sorry, that's cubed, right? So what does that equal? That equals 1 over 2 to the third times 5 to the third times 2 to the third, 2 to the third, 5 to the third. What cancels? Yeah, and you're left with just 2 to the third. Do you end up with the same answer? You sure do. Are there different paths? Absolutely. Find the one that you like best, stick with it. That's fine. Just realize there's others out there. Can it generally always help to factor if it's something that you can easily do? Yeah, it can generally only help, unless you make a careless mistake. Okay, anything else in here pique your interest? Anything? Would your answers change to this? Would it go up or down, or stay the same? Go down? You like it less as you understand more? Okay. 21. Did we talk about 21? We did not talk about 21, but we can 2 to the negative 2 over 3.
I'm sorry, that's 21 on this second part.
21 on the second part? Sure.
Yeah.
Right here?
Yeah.
3 to the half. This one? 3 to the half times 3 to the 3 halves?
Oh, do you just...
Add.
Yeah.
3 to the half, 3 to the 3 halves.
Oh, no,
Three.
It's 2 to the negative third over 3.
2 to the negative third over 3.
Yeah.
Yeah, so that's going to be 1 over... So what does it ask? Just to simplify it?
Yeah.
Well, I mean, you can 3 times the cube root of 2. That's one way you could do it. That's all you can do. There's no nice answer to that. Cube root of 2 is cube root of 2 a nice answer? No. No, excuse me, a nice number. No, it's an irrational number. Yeah. Okay. I don't know. She just shouted it out. We went with it. Okay. We're pretty good on the rest of these?
Yeah.
Are 57 and 58 meant to be too hard? No. They're meant to make you overthink, I think. You're just plugging in a number. I'm not trying to help hurt you. Okay. 800 and what?
$881.17.
People agree with that?
Yeah.
Yeah. Okay. So then the question becomes, what happens if instead of... And by the way, side note, everybody, this is really important. The interest rate is always going to be always expressed as, you can think of it as per year. Okay? Always expressed as per year. You need to do that or things get really messy. Let's say you had $500 and it's still in 12% per year, but you're going to compound it biannually. Is that twice a year or is that every 2 years? That's twice a year. Thank you. For 5 years. So let's just logic out what the equation is going to be. 500 times 1 plus
24.24.
that doubles the interest. We don't want to double it. We want to have it. But instead of doing it 5 times, we're going to do it.
10 times?
Yeah. So logically, have we changed much?
No.
Logically, we haven't. How much money do I have, though?
More.
How much?
$1,552.92.
We made more money. Made a good chunk more, right? So instead of compounding it 5 times at 12%, we compounded it 10 times at 6%. Why did we make more money?
Because every time that you're compounding it, you're having the new number of interest is greater than it was before, so you're earning more interest.
Why is it greater than it was before?
Because it's compounding it.
Because to the power affects it
The
most.
10 to the larger number is larger than a 10 to the
The
smaller.
time is going to affect it the most because it's in the power.
Essentially, the way you should really think about it is as follows. Money over time is money. $1,000 now is much more valuable than $1,000 a year from now. $1,000 today is more valuable than $1,000 next month. So if you think about it, instead of getting 12% at the end of the month, if you're getting 6% halfway through and then 6% at the end, you're getting half of the interest early every month if you did it monthly. In this case, we're getting half of the interest every year at the midpoint of the year. So instead of getting all of the interest at the end of the year, where's the interest getting added in?
Biannually.
Biannually. And then so basically you have half of the interest gets grown for the second half of the year.
So you're basically putting interest on it twice.
Half of, yes, for part of it.
Half of the money is being...
Essentially, you can't really do it half because you have to realize that the longer the money is, therefore the interest grows.
Yeah, right.
But the point is basically money is going into the account earlier, so therefore you're going to end up with more money. If I put 1,000,
More to grow.
Exactly. So, for example, let's say you owe me $1,000. I would prefer to get it right now than I would a year from now. Why?
Because you'll be able to put more interest on it.
Exactly. So when you pay things off early, when you guys start paying bills, everybody put your calculator down, put your hands up. Yay. When you put money into a bank account, or if you're going to pay a bill early, sometimes on a bill you'll see these. If you pay this within 10 days, please subtract $13.15.
Yeah.
You'll see that. That's because paying things early, well, there's different reasons for that, but paying things early generally mean you will have more time with that money.
The company that you're putting the money into.
Yeah, and here's the thing.
Yeah.
More. Yes.
Last year, $895.
Oh, you think that's wrong?
It is wrong.
Yeah, that's
$895 and what?
Sorry, guys. 42 cents.
Yeah, it seemed a little high. So the more you compound, the more the what?
The more money.
Yeah, the more the amount grows, right?
But is it worth waiting to get 5 more years to still like $10 bucks?
Wait, what? No, you're not changing the length of the loan. The only thing we changed here, it's the same length. No, it's the same length. The only thing we changed was instead of compounding it once a year, we compounded it twice a year, and you ended up with more money. The point is, the more you compound, the more money you make. So you can keep on compounding. Could we do it more than monthly? Yes, we could absolutely do it more than monthly. So let's say we went.
Daily.
Splitting stuff.
Let's do it daily.
Let's go daily, right? So if we went to daily here, before we do that, how did we get this term right here? How did we get that term right there? How did we get 0.06?
It was half.
Half of 12, right? It was 12 divided by 2, right? That was the initial rate, and that was how many times per year we're compounding. So if we wanted to do this daily, it would be 500 times 1 plus 0.12 divided by, and what's the standard number we're going to use is 360 for days.
Oh.
360. And then what power are we going to raise it to?
10.
No.
1,000
5 years?
5 times 365.
Yes. Yes. Very good. Very good. So, compute that for me. What is it? Everybody do it. On your calculator, type in 1, 2, 3, 4, 5, 6, 7, 8, 9. Hit store, STO, and then hit alpha math. So it stores it as A and press enter. What that means is whenever you have A now and press enter, it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. We divided by 360 to compound daily, right? So if we divide by 123,456,789, is that a bit more compounding? Yes. You are basically taking an infinitesimal amount of time and using that towards an infinitesimal amount of interest, right? So this is what we're going to type into our calculator. 500 times 1 plus 0.12 divided by A to the 5 times A.
Wait, how did you store it again?
STO, bottom left.
Right here.
So what did we end with here?
A lot.
Well, no, compared to what we had before. How much money did we have before when we compounded it daily? $910, right? How much money do we have now? We went from daily to compounding it basically every like millisecond, and it went from $910 to what? You didn't type it right if it was anything other than 911.059. Yes, you'll have to put a parenthesis around the 5 in the A. If you don't put a parenthesis around that, it's going to multiply the whole thing by a 9-digit number. See if you can get that number that's up there. See if you can duplicate it. It's not more money. It's not much more money, but it is more money. So the question is, what's the most? If you did it continuously, if you're doing it continuously, this is what it looks like, everybody. And this is the general equation. And it's not something we're proving because you are not there yet in order to proving it. But it looks like this. The limit as n goes to infinity of p times 1 plus r over n to the nt. P is principal, r is the interest rate, n is the number of times compounded per year. That equals p times e to rt.
But
So the maximum amount of money you can make if it's compounded continuously is 1 plus, 500 times, e to the 0.12 times t. How many years? 5. If you do that on your calculator, 500 times e to the 0.12 times 5, what do you get? Enter. Look at that.
Yeah.
Does it come out to be pretty close to what we got when we compounded it by like the millisecond?
Yep.
Yeah, is it still a little higher? Little tiny bit.
It never stops growing.
It never stops growing, but it slows down.
So it'll never actually hit that.
That's correct. It'll get
Exponential
infinitely.
function.
So what do we have? What's that called?
Or level after.
Horizontal
Oh, there
asymptote.
you go.
This is the horizontal asymptote. This is continuous interest. This is what banks use. Can someone tell me why banks would be interested in compounding as often as possible? The more you compound, the more money you make, and if it's continuous, that's the most money you can make over time. Now again, money changes hands so quickly and accounts change value so fast that continuous interest is very, very useful. That being said, you will see this all over the place on credit card. ADB, average, what is it? Daily balance. This is something you can calculate with calculus or just a really good bar graph. But how much money was in your account on average for a certain month? That's something you will see on all your bank statements. It's a very important indicator because $10 every day is very different than $50 for one day. If you're adding $10 every day, that's different. Your daily balance is important because you could have no money at the end of the month, but your average daily balance might be $1 billion. It's totally independent. But then this is what you're going to see percentage rates based on, things like that. Does anybody know when you have to pay? Like, how do credit cards make money?
When you don't make the.
How though? How do credit cards make money?
They had
When is the interest calculated?
When you spend money.
At the end of each month. Yeah, it's something. If you pay, what happens if you pay off your bill before the end of the month?
you don't have
Or
to
lower
pay the
interest.
Oh, yeah, you lower the interest, or if you were able to pay off the principal, then you don't have to pay them.
Well, let's say there's no recurring fee on your credit card. Let's say there's no recurring fee on your credit card.